Hey guys, welcome back. I'm Megan Campbell and this is Making Stuff. So in this video I'm finally going to be doing an upgrade that I've been planning for a couple of months now. I've been putting it off because there have been a couple of upgrades that I've had to do to my machine in order to accommodate this laser, but thankfully they're all done and finally today is the day that I can start with this laser upgrade. Now the laser I'm planning to install on this machine is made by Opt Laser. It is the XT8 model, which is the latest 45 watt laser, and this is it right here. Now this box I actually received a couple of months ago. Now, full disclaimer, Opt Laser did send this laser to me free of charge in return for making a video. Reason being, Opt Laser do currently offer laser kits for most CNC manufacturers out there, but currently they do not have one for the Blue Elephant machine. They reached out to me and asked if they could send me one of these to hopefully help them develop a kit specifically for this machine. Now it all happened so fast, and when they sent this laser to me, I hadn't really done a whole lot of research on how it works and what is required to run it. So only after this arrived at my door, I started doing some research and I realized that there was a pretty big issue. Now I'm going to give you a bit of backstory here, but if you're not interested in hearing that, then you can skip to somewhere around here. The controller that I had on this machine was a Rich Auto A11, and unfortunately it didn't really have the capability to run a laser. So I'll try to explain in layman's terms because I'm still trying to figure this stuff out myself. I'm in no way a professional when it comes to these kind of things, so take it with a pinch of salt, and if I make any mistakes you're free to correct me in the comments down below. So from what I understand is that this laser requires either a PWM signal or a 0 to 10 volt signal to tell the laser what power it should be using. So the problem with the Rich Auto controller is it doesn't have those capabilities. The Rich Auto controller only has 8 preset speeds. So in your VFD, if your spindle is say 24,000 RPM, you have to divide that 24,000 RPM by the 8 preset speeds that the controller allows, which in my case would be 3000, and then in your VFD you have to set it up to use specifically those 8 presets. So initially when I got this machine I didn't even know that was the case. I was happily setting up my RPM in VCarve Pro, which is what I use for this machine, and only after a couple of months of using the machine I realized that what I was setting as RPM in the software was totally being ignored by the controller. So the G-code I was bringing in from VCarve Pro was only using the movement data, but in order to change the spindle speed I had to change it on the controller itself. So basically, in other words, in order to run this laser I was going to have to upgrade my CNC controller, which after a lot of research and planning I ended up going with the Masso G3 touch controller, which compared to what I came from is a night and day difference to how I operate this machine. So if you're interested in seeing that video, I'll leave a card up here so you can go check that out if you are perhaps in the same situation as I am. So the other upgrade that I had to do was this dust shoe over here. And if you can see that, the previous dust shoe that I had on here was mounted directly to the spindle, so I couldn't really move it up or down, and it was a bit of a pain to remove. So I wanted something that I could move up and down and get out of the way if I need to, and perhaps even totally remove when I go to attach and use the laser. So I have a video for this as well. I'll leave that up there. It's not very exciting, but this upgrade allows me to move the hood out of the way, and if I don't have enough clearance I can just loosen these knobs on the side and remove the whole hood completely. So with all that backstory out the way, I think the next thing we need to do is open up this box and see what we have inside, and then we can start planning out how we're going to install and connect all of these components. Okay, so now I'm going to pretend like I haven't already unboxed this thing 3 times and go through this as if it's the first time that I'm doing it. So let's open up the box. This is my customs clearance papers. Just for interest's sake, let's have a look at the date over here. 1st of July, so that's July, August, September, October. It's almost 4 months that this thing has been here. So first thing we're greeted with is a couple of stickers, of which my son has already stolen one. Then I guess let's start with the most important part, which is the laser itself. Now I must say that I'm really impressed by the build quality of this. This is all solid aluminium. It's pretty heavy, and I have to say that the build quality is exceptional. This over here is the CNC Adapter Pro. So this is what is going to connect to your CNC controller, and this is going to convert the signal coming from your controller into something that the laser can understand. Next item over here is the Laser Dock Pro. Now from what I understand, if you buy the laser, this is an optional extra. This doesn't usually come standard with it, but I think this is definitely a worthy upgrade, and if you're going to get this laser to install on a CNC machine, I would very much recommend getting one of these. This makes it so that you can easily detach the whole laser from the machine. So this is what's going to be attached to the machine, this is going to be attached to the laser, and anytime you want to use the laser, you can just clip it on, and if you want to take it off, you just take it off. It's held on by strong magnets and some clips over here, and when you detach your laser, you have a really nice aluminium cover that you can use to cover all of these electronics. So in that way you don't have to have the laser attached to your machine permanently. You can put it on only when you need to use it. Next thing over here is a beam cover, which you're going to put over the actual laser nozzle to protect you from any stray laser beams that could be shot out. This over here is a focus tool, and lastly, in this part of the packaging you have the laser goggles, very important. And then let's check what's underneath. Okay, so here we have the power supply for the laser. I think this is going to power the CNC adapter, and then that in turn is going to power the laser. Over here we have a signal wire. This is part of the assembly kit, we'll get to that later. Then next thing over here is adapter to controller, a universal signal cable. Okay, it looks like they're giving a couple of different kind of signal cables. As I don't know if I mentioned that in the beginning, this is a universal kit, so it has a couple of different options here. So there's a good possibility that there are quite a few of the things in this box that I'm not going to need, but they're just included to hopefully make my life a little bit easier. So 2 signal cables from what I can tell. This over here, it says Laser Dock Montage Kit. I'm not exactly sure what that is. I think that is just a connection between the Laser Dock Pro and the actual laser head. This is the actual signal wire that's going to travel from the CNC adapter all the way to the laser. And then lastly, we've got a couple of mounting options over here. We've got a universal clamp CNC mount, and then we've got a mount type D. This one's got 2 separate mounting plates and an assortment of bolts. Okay, so I'm just going to roughly pack all of this stuff back in the box for now, and then we can get started with this installation. Okay, so I feel like the first obvious place to start is figuring out how we're going to get the laser mounted on here. Now initially I wanted to mount the laser on the side, but that creates a couple of issues. I can't go on this side because I've got my dust extractor here. I could move that somewhere else, but... Okay, so as I was saying before I was so rudely interrupted, I could move my dust extractor somewhere else, but I don't really feel like doing that. Also, if I put the laser on the side, I do lose a little bit of my X travel, so I decided I want to mount the laser on the front. Now at first glance it didn't look like any of the included universal mounts were going to work for me, so I spent a couple of hours designing and 3D printing something that could attach on here, which would allow me to then attach the laser. So after I did all that work, I went back and I looked at the universal mounts again, and I realized that the clamp mount would actually have worked quite well to clamp onto here. So even though I'm not going to use that, I'm just going to give you a quick rundown of how that works. Maybe that will help you if you want to use that mount. Okay, so this is the universal clamp mount. So the 2 main components over here are these, and then you have a bunch of different length screws. Each length has got 4 screws. So basically, in my case, I'd have to use the longest ones. So you'd have to decide how you want to mount it. In my case, I need the laser mounted a little bit lower, so in my case it would work best this way. And then the two screws with the hex heads go in from the top through the bracket, and then these over here are meant to go in from the bottom into these holes over here, and then you can sort of adjust this angle to get it perfectly square. So even though this is still a fairly good option, I did in the end decide to go with my own design, which I'll show you in a minute. Firstly, because I think it looks a little bit more elegant, and secondly, I did spend a whole bunch of time designing and printing it, so I may as well give it a try. If I do figure out in the future that that doesn't work, then I can always edit my design, or I can go back to this as a final resort. Okay, so this over here is the design that I came up with. I designed and printed all of these in separate components just so that I could get maximum strength for all of these parts. These two attach with screws from here. I have some nuts sunk into these brackets over here, and this fits perfectly on here, and then I have these parts that fit in from the other side, and you can tighten them with bolts from the front of here. Now you may be wondering where this comes from. This is a model of the LaserDock Pro. Now I didn't go and design all of this myself. Thankfully on Opt Lasers website they do have STL models for most of the products that they sell, so you can easily go and download the models for testing purposes, which is exactly what I did. This over here is the complete laser module. This is the other end of the LaserDock Pro, and as you can see, this will attach on there like that. So as far as testing is concerned, I think my prototype works. So I didn't make any other changes to this design. The only other changes I made was to the printing. This I printed on 25% infill, and they are pretty strong. But for my second design, I did go ahead and add modifiers to all the places where there are screw holes going through, and I changed them to be a solid print. So the rest of the prints are still 25% infill, but then all the important parts are 100% solid. And in this part specifically, I added a solid strip all the way from the top to the bottom, so that should make it a whole lot stronger and it won't be able to bend at all. So those parts I finished printing it yesterday, and this is them right here. The only other design change I made is I beveled these edges, so that should look a little bit nicer. Okay, so I'm going to get all of the hardware from this moved over to the final mount, get it mounted on here, and then we can go ahead and install the actual laser. As you can see, these machine screws over here are sticking out a bit, but I'll just take a file and file those down so that they sit nice and flush. Let's get the next one on. Okay, so after quite a bit of filing, I've got everything nice and flush, but before I can mount this, the laser dock needs to be installed from the back. I'm going to attach this here using these machine screws. Okay, that's the laser dock attached, so let's attach all of this to the spindle. So even though it's probably not going to make a difference whether this thing is square with the x-axis, I'm still going to go ahead and try and get it as close as possible, at least by using a square against this mounting block. I think the main issue is having it square with the bed, but that is as close as I think I need to get it. Let's stick these in. Okay, that seems pretty strong. Doesn't look like it's going anywhere. So the next thing we need to do is to attach the other half of this laser dock onto the laser module itself. So let's do that. Okay, let's first attach the laser dock. I'm going to use the second set of holes. I'm going to try not to over tighten these. I'm just going to tighten them lightly. I don't want to run the risk of stripping those threads out. So that's good. Okay, next we have to install this air line. This goes in the top here. We've got to feed it through all the way down to the bottom over here, and it has to be connected here. Let's twist this around all the way through, stick it in there, and then pull this down again. Okay, I think that'll do. And then I think this gets connected over here. So that's about it. Let's see what it looks like on the machine. Okay, stick it on like this. Wow, I think that looks pretty good. Okay, so with that done, next we have to start figuring out all the wiring and all the connections. Okay, I've just got to backtrack here for a second. I've forgotten to attach the cable that connects the laser dock to the laser module. That's in this laser dock montage kit. It's this cable. So let's just loosen these. Okay, that looks good. Back on the machine. Okay, so the only cable that needs to be connected to the laser module is this cable over here. And this has to go all the way to the CNC adapter, which is this. Now my plan has been to install the laser adapter somewhere in this region. I want it slightly hidden because there's going to be this key sticking out here, and I don't want to run the risk of breaking that off. So just slightly behind the CNC controller screen, something like that I think would be a good spot. Now the only problem is I don't know if this cable over here is going to be long enough. I've calculated I'm going to need roughly 10 meters of cable to get from there all the way into this box. Even then I don't know if it'll be able to reach all the way to here. I'm going to snip these cable ties off and measure this cable and see how much I've got here to see if it's even going to be possible to mount it here where I want to. Okay, I've just gone ahead and measured this cable. It's roughly 7 meters long, and even though I've kind of overestimated what I need here, I still think that 7 meters is going to be too short. But that's not the end of the world. I'll remove one of these, and then I'm just going to have to look around locally and see if I can find another 6-core cable so that I can extend this if I need to. I will obviously take pictures of all of these just to make sure that I have the wiring correct. But next I'm going to have to plug the one end in here, and then I'm going to have to start figuring out how to get all of this cable through all of the drag chains and into the control cabinet. Now thankfully this is something that I've done recently when I did the controller upgrade, so I've already got a fairly good idea how I'm going to go about it. But I'm not going to step by step you through that whole process because that's going to take a while. So I'm just going to do what I can now, and then I'll check back with you later and show you what I've done. Okay, so clearly quite a lot has happened since the last time you were here, judging by this giant big mess we have. So I went ahead and I took most of the components off that I needed to in order to fish this new cable through. I could unfortunately not fit the cable into this housing over here, so I just had to cable tie it along the inside here. But with a bit of effort I did manage to get the cable through all of the drag chain, and as I suspected the cable was roughly about 2 meters short. So yesterday afternoon I went to a couple of local electrical stores and I couldn't find any 6-core cable. But then I remembered that the last time that I did the CNC controller upgrade there was a redundant cable that I removed from the machine, and that is this one over here. Now this is actually a 7-core cable. The only problem is that the wires on the inside of this cable are a whole lot thinner than the ones that are on this cable. But due to lack of any other options, I decided to go ahead and extend the cable using this. I went ahead and I spliced this cable into the other cable and fed everything through the rest of the system into the control cabinet. I did also use the multimeter to test continuity between all of these wires wires, and fortunately all of them seem to be connected properly. Now, I'm no electrician, but I did notice that when I measured the continuity, it was showing a resistance of 0.6 ohms. Now, I don't know if that's a good thing or a bad thing. All I know is that if I put the two prongs together, there's a zero resistance. Now, I don't know if that resistance is going to cause any issues, but it does have me a little bit worried. So this morning I went to an engineering supply store and I managed to find another 7-core cable which had much thicker wires. In fact, it's even thicker than the original. So initially my plan was just to buy an extra 3 meters so that I can splice that in, but then I decided to rather just buy 12 meters in total and replace the whole cable from here all the way into the control cabinet. So this is the cable right here. As you can see, it's quite a bit thicker than the original cable. In total, this one is about 9 millimeters and this one is 7. So this is about 2 millimeters thicker in diameter. Now, even though it was quite a bit of PT to get this fed through the whole system and into the control cabinet, pulling a whole new cable through should be a whole lot easier because the cable's already there. So all I can do is just tape the end of this cable to the end of the other cable and pull it straight back through again. That shouldn't be too much work, and while I'm at it, I do need to also install an air line for the laser. So I'm going to attach that tubing to this cable and I'm going to pull them all through at the same time. Okay, so I got the new signal cable and the air line pulled through all the way through all of the drag chains and out into the control cabinet. Thankfully it was fairly simple because I already had a wire pulled through here. So all I had to do after that was cut off the old connector from the old cable, connect it, which I have over here. Here at the bottom is where the air line goes in. I bought this little elbow fitting from the same place that I got the tubing, which was a pet store, as this is aquarium tubing as well as aquarium fittings. Now, the reason I have all these aquarium parts is because the air compressor that I'm going to be using in here is in fact also an aquarium pump. This is it over here. I'm hoping this will be sufficient. I think it should be. I have a similar pump to this running on my CO2 laser back there. I've seen other people running their lasers with similar pumps, so I'm hoping that this should be sufficient. Okay, so we're obviously still a long way from being able to put all this stuff back together. The next thing I need to figure out is where I want to mount the CNC adapter so I can figure out how I'm going to get the wiring to it as well as the power that needs to supply it. Speaking of power, another thing that is also going to require power is going to be the air compressor that I'm putting in here. So with all this talk of power, I thought I may as well do something that I've been planning to do on this machine for quite some time. And that is to get switches somewhere in the front of the machine here, which I can use to activate the water pump for the spindle cooling as well as the dust collector. Currently both of those things are plugged in at the back of the machine. So every time I want to use the machine, then I have to squeeze into the back over there and put the plugs on manually to activate the dust extractor and the spindle cooling pump. So in order to do that, I went and I purchased a standard light switch like this, and then I went ahead and 3D printed a box for this to go in, and the idea was to have this mounted somewhere in the front over here. So all three of these devices are 220 volt. There is a 220 volt mains hookup inside the machine, but I don't know if I can piggyback off of that line and if that is going to create too much load for the circuit breaker and give me problems down the line. So what I'm going to have to do is I'm going to have to pull a separate cable from each one of the devices to here, and perhaps more separate cables all the way back to the plug at the back there. So as I mentioned, I wanted this box to go somewhere over here, and my plan was to have the adapter somewhere over here. But the more I thought about that, the more it didn't make sense, because I've got to have power coming to here and I've got to have power coming to here, and I also do not want to have a messy situation where I have cables coming out here or cables coming around here. The only way that I can do this wiring very neatly is to drill holes into the machine over here, and as this is one large box section of steel, that means I would have to drill holes on the inside over here and somehow fish the cables through. And the more and more I thought about that, the more I didn't like that idea. So after a whole lot of thinking, I came up with a new plan. So instead of mounting the switch and the adapter separately on the front, I decided to mount them together on the side of this leg over here. So I went ahead and I printed a box to house all of these parts. As you can see, these fit in perfectly over here, and this will be mounted right on the leg over here. Now the reason I chose this leg is because, as you can see, on either side of the leg there are access plates to feed cables into the leg. So if I drill 2 or 3 fairly large holes over here, I can feed the cables into the box section and then out of the holes and into my mounting box. Obviously I won't be bringing the cables around this side. There is an access hole at the bottom inside the control cabinet, as well as another access hole into the leg around the corner, so I can come into the control box and into the leg and then and into the box. So as I'm going to have a whole lot of power cables running from the control box all the way to the outlets at the back there, I didn't want to have all the cables running along the floor here. So as you can see, I 3D printed these brackets. It's a pretty basic design. You can just pop the cable in here and it won't be able to come out. And I left more than enough space here to run more cables through. So I'm going to start extending some cables, dragging through some new cables. I'll drill large holes into the leg here for cables to pass through, as well as drill and tap holes for the mounting screws for mounting this box. So unless anything interesting pops up, I'll check back with you once that's done. Okay, so I've basically pulled through all the cables that I'm going to need here. I've marked all of them, and one of them is going to be for the dust extractor. One of them is the water pump for the spindle, and this thin one over here is the compressor for the laser. This red one over here is going to be the main power that's going to go back to the outlet. Initially I was going to take one back for each of the devices, but I don't think these items are going to draw that much current that I'm going to need to put them on separate circuits. The only thing that could draw quite a bit of power is the dust extractor, but the little submersible water pump and the little air compressor, I don't think they're going to draw that much current at all. So as you can see, also I have gone ahead and fed all the cables through these clips that I made. So the only thing that I still need is to either get a longer one of these or lengthen this cable. If I need to lengthen it, I don't have the cable I need, so I'm going to go and see if I can get a longer one. If not, just a longer cable so that I can lengthen it. And this will be plugged into its own outlet at the back of the machine. So that's about as far as I'm going to be able to go today. I have to go pick up my kids from school, and then my son and I are heading away for the weekend for an inline hockey tournament. So I'll only be able to carry on with this on Monday. So see you Monday morning. Okay, I'm back. It's Monday and I've gone ahead and pulled all of the cables that need to be here. I've also pulled through the signal cable going to the laser, and I've also pulled through the signal cable going to the Masso CNC controller. So all that's left now is to get everything wired up. I've gone ahead and printed a new enclosure as I was having issues with power cable coming out of the CNC adapter. It was interfering with the switches over here, so I moved this across to the side a bit, brought this down a bit to give me a little bit more room, and it should be a better fit. So I'm going to get everything connected up here, and then I'll show you what it looks like before I go ahead and close everything up. Okay, so this might look like a mess, but everything is connected here the way I think it's supposed to be. Here's just the cable for the adapter. Here I've stripped and wired up all of the wires that are going to the laser itself. These are the two signal wires going to the Masso, as I mentioned before. Over here you can see I've stuck together all of the ground wires, stuck together all of the neutral wires, and all of the live wires are going through the plugs. So I have already tested them all. I'll just show you. This one is the water pump for the spindle's water cooling. It's just very soft, so you can't hear that. That is the air pump, which I've already installed inside the cabinet. And this, as you can tell, is the dust extractor. So it seems everything is working as it should. So I'm just going to stick everything in the box, mount it, and we should be mostly done with this installation. Now I'm going to do some cleaning up here, and then we can do test fire on the laser, see if all that works. And then the last thing we'll have to do is perhaps do some test cuts, test engravings, and see how this works. Okay, so it's actually been a few days since I've been able to carry on with this project. I got a couple of commission jobs in that needed to be done urgently, so I slapped on the cover over here and I've been doing those jobs for the last few days, and finally we can get back to wrapping this project up. So in the last clip you saw me wrap up the wiring in the box on the side over here, and now before I go ahead and put everything back together again, we're just going to check that the wiring from the CNC adapter to the laser is done correctly, and then once we're sure that the laser can actually produce a test fire, then we'll go ahead and check whether the connection to the Masso controller is correct by assigning it to one of the outputs on the Masso and activating it to see whether the laser will fire or not. Okay, so the first thing we're going to do here is do a test fire. Now technically the machine doesn't need to be on for this because the laser and the CNC adapter are wired separately directly to the outlet. So basically in order to test fire it's not really necessary to have the machine on. So let's go ahead and do a test fire. I'm going to use my phone camera here to give you a better view of what it is that I'm doing. Before I do that though, let me just put on my safety goggles. So first thing you need to do is grab the key and turn the module on. Next thing you need to do is arm the laser, so you just press that button once and you'll hear immediately the fan start running. That means that it's activated, or shall I say armed. Make sure that it's on half power over here. So here we've got full power and half power. I'm just going to leave it on half power, and then technically should be able to just hold in this button. Once you keep it in, it asks for a duty cycle, so I think let's just choose like a 20% here and then hold on the laser. Okay, there we go. We've got a test fire, so that means that the wiring, at least from here to the laser over there, is done correctly. Okay, so now that we know that the laser is wired up correctly and it's firing, now we just need to make sure that the wiring from the laser adapter to the Masso is done correctly. Now there are a bunch of videos and documents online showing you how to do that. The wiring for this setup is pretty basic. On the right hand side of the CNC adapter there are a bunch of inputs. Now input number 2 is wired to output 11 on the Masso, and input number 4 is wired to a normal ground on the Masso, and that should basically be the minimum required wiring to get this thing to work. So let me show you quickly how I'm going to test whether it's wired correctly, and once that's done we can do the final setup. Okay, so the first thing that we need to do is we need to go to the setup tab over here, and then we'll see output 11 over here is the one that the laser is connected to. So if we double tap that, what we're going to do initially is just connect this to a random auxiliary. And then what we're going to do is, with that selected, if we hit spacebar, it should switch the status from low to high, which means that will fire the laser. So let me just put on my goggles here quickly, and we're going to hit the spacebar. Okay, nothing's happening. I forgot we have to activate the laser here. Just arm that quickly, and then with the laser armed, you can hit spacebar again. And as you can see, it's firing. So let's just disarm the laser again. With that test, we are sure that the wiring is done correctly, and output 11 is in fact triggering the laser. So what we're going to do now is just double click output 11 again, and then we're going to go all the way down here. Right over here is laser engraving, PWM. PWM stands for pulse width modulation, and that is how the laser is being controlled by the Masso. So let's just select that. And then this is actually something that I've already done, so I'm going to go to multi-head and we're going to go to laser engraving. By default this is off. All you need to do to complete the setup is to tick this box, and then by PWM frequency hertz you have to input 10,000 and save, and that should be just about all the setup that is required to get this laser to work. Okay, so with that I feel fairly confident to go ahead and put everything back together, put all these shrouds and covers back on, make sure that all the wiring inside the cabinet is all buttoned up and neat, and finally then we can go ahead and do some test cuts and engraving. Now, I haven't given too much thought about how I'm going to control this laser and what I'm going to use to create my files, as whichever way I decide to do it, it is going to be a little bit more cumbersome than using my CO2 laser. Reason being, my CO2 laser is connected directly to a computer and I use light burn to control it. So working on the CO2 laser is very simple and very quick. So as far as I know, there is no way that you can connect the Opt laser when running on a CNC controller like the Masso directly to a PC and using it that way. So the only way to use this is to generate G-code files, send them to the Masso, and then run them that way. Now, I'm sure that there are many ways to do that, but I'm going to be using one of two ways. I do have a subscription for Lightburn, so ideally I would like to use Lightburn to generate my files for the laser. Alternatively, I also have purchased Vectrix VCarve Pro, which I use to generate the files for my CNC. Now, apparently there is a laser module add-on that you can purchase for VCarve, which means that you can create and generate laser files natively inside VCarve Pro and then send them to the Masso just as you would with the CNC files. Now, I'm not exactly sure which one of those is going to be the easiest. For the first couple of tests, I'm going to be using Lightburn, firstly because that's not going to cost me any more money. And secondly, Lightburn does have a whole bunch of really nice calibration tools that you can use to set up the speed and power for different types of material. So that may be one of the first files that I will try to run on this machine. So I'm going to use this evening to do some research and generate a bunch of files that I can use for testing on this tomorrow morning. So let me go ahead and put everything back together and I'll check back with you tomorrow morning. Okay, so it's time to do some testing. For those of you that are not familiar with this piece of equipment over here, this is in fact the height adjustment bed that I made for my CO2 laser a couple of years ago. So the file I'm going to run is a basic material cut calibration, and I don't want to be running the machine too quickly because this is a really large, heavy machine, so I can't exactly be using the same types of speeds that I use on my CO2 laser. So I've set this to run a minimum of 1000 millimeters per minute and a maximum of 10,000 millimeters per minute. So I have my CNC turned on. I have changed the tool on the Masso Touch to 111, which is the tool that is assigned to the Opt laser. So now I'm going to turn on the laser adapter, focus the laser head, and we should be able to start the cut. Now, thankfully, I've managed to get my dust shoe just far enough out of the way to where I think that I will be able to use it without having to take the whole thing off, but we'll see how it goes. Okay, so that's where I need to have the laser focused, so I'm going to zero my Z-axis over here. And I'm going to switch to another coordinate system over here because I don't want to use my standard one. So I'm going to use G59. I'm not exactly sure how big the test square is. So I'm going to zero my laser in this corner over here. Zero my X and my Y. And see if this works. Switch on the laser. I've loaded up the cut test file 10 by 10 and it's displaying the correct job over here, which is good. So I'm going to run back to program, hit rewind. Before I cycle start, just showing you here, I'm running it with half of the diodes, which is 50% power. I'm first going to do the test over there and then I'll do the test again, perhaps on 100% power. Let's hope this is going to work. To cycle start. Just hit emergency stop. Okay, I'm not exactly sure what happened there. Looks like the laser ignored the home position that I set over there. And it ran all the way back to the bottom left corner of the machine for some reason. We just first try and figure out what happened here, and then we'll take it from there. I'm not exactly sure what happened, but somehow it defaulted back to G54. G54 has got its origin at the bottom left of the machine. I don't know how that happened, but I'm back on G59 again. So I'm going to hit rewind and cycle start and see if it works this time. Okay, wait, I'm going to hit emergency stop again. Not exactly sure why that's happening. Every time I run the job, then it goes back to G54 work offset, which makes no sense unless the G code is specifically calling for that work offset position, and I don't see anything like that in here. Let's do some more troubleshooting. Sorry. Okay, I don't really want to change the G54 offset because that is the one that I use 99% of the time. But until I figure out why the G code for this job keeps on defaulting back to G54, I think I'm just going to go ahead and do that. I've repositioned the laser to where I want it, X, Y, and Z. So I'm just going to 0, X, Y, and Z. And just for safety, let's just reload this file. Let's go back here, hit rewind, and see if it works now. Okay, stop again. Now I forgot to arm the laser again. Seriously. Arm the laser and give it another try. Shows the laser is firing, but I don't see anything happening here. It's clearly running through the G code, but I don't see any light coming through there at all. Okay, somehow it's running now. I think my settings for the text were too low. So now when it's coming to the actual squares, it seems to be working. Okay, so it doesn't look like any of these cut through. Looking at the back, a couple of them shot through in the corners, but none of them went all the way through. Another thing that I've noticed as well, I don't know if you can see that, my lines running across the x-axis seem to be fairly straight, but the lines running on the y-axis are a little bit squiggly. So I'm not exactly sure what the problem is there, but I'm going to rerun the file at 100% power and see if the result is any different. As you can see, I've only got 3 squares cut out here at 190 and 80% power at about 1000 millimeters per minute. So basically, if I want to be cutting 3mm MDF, those are the settings I'm going to have to be using, 1000 millimeters per minute at 100% power. I will also say that I'm not extremely impressed by the fine detail, but I'm guessing it's to be expected because this is a really big machine and it's not really geared towards small fine work. I think for things such as engraving, where it's rastering an image back and forth, that might give me better results. But for cutting such small things out, I just think this machine is too big and bulky to do such small fine movements. But I could be wrong. I will do some research and see if there's any way that I can come up with better results than this. That being said, I think that 50% power on the laser is definitely not sufficient for any sort of cutting. If I'm going to be doing cutting, I'll have to be sticking to 100% power, but I'm going to do a test now, just find some kind of random PNG image online and run an engraving at 50% power and see if that works. Okay, that seems to be doing something. Okay guys, I think I'm going to call it quits here. I haven't had a whole lot of time to do more testing on this, but I realized that that is anyway outside the scope of this video. The whole point of this video was just to get this upgrade done and get it working, and I think that I've achieved that. All the wiring and plumbing is done and the laser is working. So I feel like doing a whole bunch of testing to get everything dialed in is just going to be a little bit overkill. Dialing in the settings for any laser is potentially quite a time-consuming job, and I feel like that should probably be a video on its own. So if there's anyone who's interested in seeing that, just drop it down in the comments below, and when I get the time I will certainly do an update video and go through that in a little bit more detail. So the only other testing I really did was playing around with some of the overscan settings. You can see some of the engravings that I did over here. This lettering at the bottom is exactly the same as the one on the far right. Because my overscanning was very low, the laser has to slow down to almost a stop when it changes direction and come back and do the same on the other side. So your engravings at the ends are much darker and much deeper than what the engraving is in the middle. So when I did the test over here, I increased the overscanning to 10%. So basically 10% of the overall length is what the laser will overshoot to compensate for that slowing down and speeding up process. And over here the engraving looks a lot better. Out of these three on this specific material, I think 25% power at 10,000 millimeters per minute is going to be the perfect settings for this specific material. Another test I went and did is cutting tests based on what I saw with this material test square that I did over here. This I cut at 800 millimeters per minute at 95% power, and it cut through here like butter, no issues there. Another thing that I'm still going to have to figure out at some point is the shaking at the corners of here. I'll show you a close-up here now. You can see that everywhere where it reaches a corner, obviously there's some jerking in the machine. When it stops abruptly and starts moving in another direction, there is a slight bit of wobble in the laser on each of the corners. I did a while ago watch a video, JN Woodworking I think it is, Jim Neeb. He's fairly clued up on these type of lasers. I seem to recall him having issues like this as well, and I just have to go and check what exactly he did to remedy that, and if it's even possible to remedy that. I've got one last test engraving that I'm going to do on here just to test something else out. You saw a little earlier in the video that I was struggling with the laser continuously defaulting to the G54 coordinate system, and it seems like if you export G-code from Lightburn, no matter where you set your start position, whether it's current position, absolute coordinates or user position, I've tested all of them, and it seems that if you export the G-code, there's always going to be a G54 command inside the G-code by default, and there's no way that you can change it in Lightburn. But thankfully the Masso G3 Touch has G-code editor built in, so you can open up any G-code file, hit edit, and you can go change any of the G-code lines inside the file and save them, and they will update. So all I basically need to do is export my G-code from Lightburn, send it to the Masso, and then before I run the file I just edit the G-code, change G54 to G59, and hopefully my file will start cutting where it's supposed to. So I know that I can change the G-code, but I haven't run the file yet to see if that works. So that's what I'm going to do now, and then I'm going to be pretty much done with this project. Okay, so I'm just going to show you how it's done. By default, when the machine starts up, it'll be on the G54 work offset. Here by tools and offsets, you can see G54 is my standard bottom left. Obviously not anymore because I had to change it when I was doing the last testing. Here, as you can see, G59, I've gone ahead and changed to laser. So now every time I do laser work, I'll change my coordinate system to G59. And then I can zero my X, Y, and Z axis wherever I need to without affecting my standard coordinate system. So to switch obviously is exactly the same. You just go to MDI command, G59, run. So now we're in the G59 coordinate system. Now let's just go to load file. So I've got two files here. One of them engraves from top to bottom, the other one 180 engraves from bottom to top. So I'm going to choose that one, hit load. This one's going from bottom to top. So if I edit this, you'll see that G-code over there is G54. So if I select there, backspace, change that to G59, save, exit, see it's rerunning the file, and now if you edit it, you'll see that it's G59. So if you go back to program, you'll see here in the G-code it is updated to G59. I'm already on the G59 work offset. I focused the laser, zeroed all my axes, so all I need to do is hit rewind, start up the CNC adapter, arm the laser, and if I hit cycle start, everything should be as expected. So let's give it a try. Turn on laser, arm laser. And then because I'm engraving, I've switched to 50% on the laser itself, so I'm only using half of the laser diode. The only problem that I've just thought about now is that this file is doing an engraving and then a cutout as well. So that's going to mean that my cutout isn't going to go all the way through. But that's fine, I'm going to run the file and let's see how it goes. Okay guys, this is going to be the end of this video. I'm really happy with my final test. The engraving is really clean and crisp. It looks really nice. Obviously the cutout around the edge didn't go all the way through, but we knew that already because the laser was set to 50% power. So I'm not exactly sure what my workflow is going to be in terms of that, if I need to do an engraving and a cutting in the same job. I'm guessing that's just going to be something that I'll have to do in 2 separate G-code files, which is not the end of the world. The other thing I could possibly do, which I'm not sure if I'm allowed to, is switch from 50% to 100% on the fly just before it starts cutting. But I'm not really sure if that's possible or if that will damage the unit. I will reach out to Opt Laser and ask if that is something that I can do. But in the meantime, I'll just stay away from that. So my final thoughts, I'm really happy with this upgrade. I'm certain that I'm definitely going to be using this a lot in the future. It's going to be really nice to have the capability of doing laser cutting and engraving on such a large bed. So obviously a couple of things that I'd like to do in the future is some kind of cutting surface dedicated to the CNC, something that I can easily put on the machine and take off without too much hassle. Now, obviously if I'm just doing engravings, that's not going to be a problem, because I can engrave straight on the spoil board on my machine. I know that's flat, everything's good. It's only when it comes to cutting that I'm going to have to somehow raise my material so that I don't cut into my spoil board. The only other thing that I may need to do in the future is to come up with some kind of system for extracting the fumes produced by the laser. My CO2 laser has got a fan and I've got ducting all the way to the outside of my workshop. So at some point I might have to tap into my existing ducting and perhaps bring another hose somewhere in this vicinity that I can easily install and uninstall when I need to, so that I can extract the smoke and fumes produced by this laser. Now when it's engraving, it doesn't create too much smoke, so that's not really a problem. It's only when I'm doing cutting that it does produce quite a bit of smoke. And if I want to at all be working inside the workshop while this laser is running, I'm going to have to come up with some kind of solution for that. But these are all plans for the future. I may do videos for those, I may not, we'll have to see. But for now, I'm just glad that we've gotten this far and everything is up and running. One last thing I wanted to mention is that I noticed the last time I put the laser onto the laser dock, even though it clips in nice and strongly with the magnets, there is a bit of movement. I don't know if you can tell if I move this around. And that may be the reason why I'm getting all of this rippling and vibration when the machine changes direction abruptly. I'm not exactly sure why it is like that. One thing I did notice is that on the website I saw that the laser dock system has got these metal plates that you can install on the side of the laser dock, so that when you install it, it kind of keeps the laser centered and stops it from moving around. Now for some reason I didn't find any plates like that in my box. I'm not exactly sure why that is, but I will definitely bring that up with Opt Laser as well. I'm not too worried about it. That is definitely something that I could probably make myself. I could 3D print it, I could cut it on the CNC. There's a number of ways that I could create those plates. So that is something that I may also try to do, just to see if that helps alleviate some of those issues. So with all that said, thank you very much for watching. I hope you enjoyed this video and this upgrade. If you did, it would be great if you like this video and perhaps share it with your friends. And if you have any questions regarding this upgrade, perhaps my Masso upgrade that I did previously, or my Blue Elephant CNC in general, you're more than welcome to post them down in the comments below, and I will do my best to answer any of those questions. One last thing that I've forgotten to do, just move this out the way. Let's go ahead and put a sticker on here so we can represent. Let's put this right here. There we go. Blue Elephant powered by Masso and Opt Laser. You can go ahead and stick one of these on here too. Stick this one up here. There we go. Okay, that's a wrap. So as always, till next time, keep making stuff.